This one, right?
Yes, please.
Do you want me to just show it to you first?
Okay, well, we'll just get things started. I'd like to introduce our next speaker, Mike Spencer from Smart Data Foundry. Mike is a research data scientist at the Smart Data Foundry with experience working in finance, environment, social sciences, and economics. Mike loves the delicate process of combining disparate data sources to answer real-world research questions. Corporate data, citizen science data, remote sensing, model outputs, all of these sorts of things. So Mike is going to talk to us about defining data links to accelerate dashboard development.
Fantastic. Thanks, Tom. Thanks for the introduction. I've put some links on the screen. I guess like many people, I'm taking the leap from Twitter to Mastodon. I still have a Twitter account, and you can probably guess what the handle might be. But do feel free to follow me on Mastodon or email me. The contact details will be up again at the end of the presentation. So I thought we should leap straight in with a challenge. And obviously the best thing to do when you have a challenge before lunch is to pick an audience member like Liam at the back, who's not paying attention. No, I'm far too heavy. So can you wireframe a dashboard? And actually it was, can you wireframe a dashboard for me? It was a question I was asked at work a few months back. I'm like, wow, that's a lot of things going on in that small sentence there. For someone who works in data science, and I'm used to having actual data and an actual end product to make, the idea of wireframing a dashboard seemed entirely alien. But actually what I'm going to do is I'm going to stop there, because maybe all of that just seems a bit abstract. I mean, it continues to seem abstract to me, but hopefully it won't by the end of the talk, especially if you ask good questions. But so as Tom said, I work for the Smart Data Foundry. For those that know me, I've been various other places over the years, and I don't know, it's the great thing about data science, you get to play in everyone's garden. So what we are is we are effectively a startup at the University of Edinburgh, and we, unlike most startups, we were very lucky that we got about 5 years of seed funding. And our purpose is, and as much as this sounds very much like the corporate tagline, because it is to open financial data and close data sets for the public good. So that's things like individual banking data that we work very closely with financial partners to anonymize their data so that it can be used for research and for public use, while protecting the anonymity and privacy of those accounts that may or may not be included. And we are doing various things around stop the squeeze, so that's, poverty and cost of living kind of crisis, things around climate change, and again around inspiring financial innovation. If we can help, because financial data is rightly very closed and difficult to work with, if we can make things easier, and this will become more apparent in the next 20 minutes, if we can make things easier for organizations to try out ideas so that they can succeed quickly or fail quickly without having to go through the rigmarole of going to Lloyd's or going to another big bank and saying, please can I have access to your customers' data to try out this idea that may or may not work. You can imagine how that call goes. Then hopefully that is us meeting our missions. So back to this request for can you wireframe a dashboard? So this came from one of our managers, and actually, like, as unreasonable as I personally think it is, it's actually an entirely reasonable thing to have asked, and that they wanted to take something to a client and say, look, if you work with us, this is the kind of thing that you'll get out of it. It's classic kind of startup or bed development kind of work that they want to showcase what might happen if you come and work with us. If you share your data with us, then we can start producing these things for you and help other people. But actually, as I say, as a data scientist, that's really difficult. And for me, it gives me a bit of an existential crisis. What am I doing? Am I actually working with data, or am I having all sorts of problems, and I think I'm working with data, and then I go and meet the people that I'm meant to be working with, and I just come away silently screaming? Not always, but and I think this is, I suppose it's the broad church of data science. It's a really difficult thing to tackle. And I think like Anita talked a little bit about this in her keynote. But what do we mean by data science? Like, are we talking about just taking existing data sets from existing providers and turning that into something else? Or are we talking about the methods that go into doing that and the reproducibility? Or are we talking all of those things? And how does all of that work together? And I guess like maybe I should take a side note and say this is what I understand of as a wireframe. That it's, you know, whether it's a poster or a website or something like that, it's purely like a, you know, skeleton structure that you can drop information in. So I'm not actually sure it's quite what they wanted, but if that's the language they use, then so be it. And that actually what that just highlights for me is that there's a gulf between disciplines, like this very sort of technical role of data science, whether we're talking about GIS or you know, sort of more number crunchy statsy type stuff, or you know, all of that grey area in between, overlapping it all. What we have to do is find a way to come together and work across these disciplines in order to achieve more than we can on our own. Liam and I were talking on the train on the way over about how hard it is to function in sort of in a modern workplace where your outputs are expected to look super professional and polished. And actually that requires a really high degree of computer literacy to do it. But at the same time, you need that subject discipline, whether, you know, like Liam, you're working with marine data, or me with financial data, or, you know, all of any of the other data sources that are going on. And it's becoming increasingly difficult for one person to have those two skill sets in enough depth. So actually what we have to do is just work across this gap. And here we are, 12, 13 slides in, and I haven't actually mentioned maps yet. So I probably should do that. And I think like maps are super important. We all love maps. Like, I'm preaching to the converted. But like they really do tell a story, and they help an audience engage. And like the immediate thing you do when you're presented with a map of data is, I wonder what it's like in my local area. You zoom and see what's going on. Yeah, that matches my expectation, or no, this is nonsense. And actually that's exactly the same for us. And maybe compared to say 5 years ago or whatever, like the kind of maps that I produce are very different, but they are still, I suppose, like equally valid and fit within this. So much of the work that we produce is around sort of administrative boundary type things. So this is some work led by Paola, my colleague, working with Sage, the payments provider, for want of a better description. So she's looking at small to medium-sized enterprises and the change in how late payments are. So the figure on your left is the situation from sort of 10 years ago or so, saying that invoice payments were, you know, sort of 60 odd days late in some parts of the country, particularly the West Midlands. But now that situation has improved 10 years on, and it's, you know, sort of half or a third of that. And I think this is, it's a really powerful story told in super simple terms about the transition from paper-based billing to electrically based billing. Like we heard in one of in Tim's presentation that we shouldn't think of money as a dirty word. Like it's, I don't know, maybe I would say that now since working in a fintech, but like we all need money to get by. Like we all paid some money to get here in some way, whether it was for our shoes or our train fare or whatever else. But like it's like it or loathe it, like we have to work with it. And so this idea of actually moving your payments from sending an invoice in the post and then expecting someone to write out a check or whatever else, and then it come back, it's like, of course it's going to be late. And then switching to, you know, whether it's BACS or faster payment or sort of PayPal or whatever else, and like inevitably it's going to be much quicker, that people deal with things when they first arrive, or even when they, if they don't deal with things when they first arrive, at least there's not a week of posting and all the delays inherent with that. Trying to remember what my next slide is, but I guess we can all find out together. So where does that take us? Some map examples. So some of the things I kind of picked up from our missions, we've been working on things around climate change, around the cost of living, around fraud, and around COVID impacts. I'm going to talk about the first two a bit more, but I'll actually probably the third one a little bit as well. But I'll mention the COVID impacts very quickly. One of the main things that we've produced over the past 2 years are dashboards to the Scottish and UK governments and associated organisations like the Bank of England and things like that, to help them explain the impacts of their policy choices around COVID. So when the country has gone into lockdown, how many people switch from getting a salary to switch to having benefits, or how much disposable income do they have left? Like how stretched are people? And that doesn't mean that our dear leaders make what we might see as the best choices, but at least we would hope they are more informed choices than they might be. And obviously, like maps play a part in that. That you want to know where are different things happening. Is it is it rural areas? Is it urban areas? All of those kinds of questions. So I guess there's a bit of a common thread, at least for me, between these data sets, and thinking back to the example of Paula's work, that geographic boundaries don't actually change that often. I mean, like, don't get me wrong, it's a pain that things move every 10 years when we get a new census, but they don't shift that often. And particularly if we're working with point data, then we can come out with actually quite a common and consistent data structure that maybe moves us a bit closer to that target of being able to generate a wireframe dashboard or a dummy example of something that we can put in front of a client or a collaborator and say, look, is this the kind of direction you want to go in? And I guess like the quicker you can get to that point, the better for everyone involved. So I guess like this is a bit of a stab about what that potential data structure might look like in super simple terms. So we've got a place there. I mean, like it could easily be 2 columns with an X and a Y, or lat and long, or something like that. We've got columns about how rainy it is, and clearly it rains more in Glasgow. A bit about population and whether or not it's hosting phosphor G. And then we can add a date column down the side there. And so I think we're all fairly familiar with that kind of a data structure. Like whether we want to call it tidy or third form normal or anything else, like we can all recognize that and think about opening that kind of thing in QGIS or whatever kind of software we want to play with. And so what I thought I'd walk through is a little bit of cost of living work that we are doing for various local authorities, roughly in this area, sort of Glasgow and beyond. Not specifically Glasgow, but sort of areas around about. I appreciate it's not the neatest of screens, but actually what I wanted to show you is just a dump from a spreadsheet. Like we're all familiar with opening data in spreadsheets, whether we admit it or not, we do it. And so what we've got as our far left column, we've got the data zone, that sort of administrative region, area, boundary that is lingua franca within Scottish local authorities. It's what they want to use to say, where do I need to target resources? We've then got X and Y coordinates for the centroids for each of those data zones. And then we've got some, in this case, entirely imaginary data around income and expenditure, maybe travel distance to work, the amount of childcare places within the local area, all the things that you might imagine might play some role on the current cost of living crisis. And then actually what we want to get to is some kind of web app that we can share with a collaborator and say, is this the sort of thing you need? Does this make sense to you? Is this the direction of travel? Like what extra things do you want in here? This is the kind of way we are imagining presenting data that that you can scroll through, that you can, and I was going to do a live demo, but given Tom stressed it off. No, it's fine, Tom. If anyone would like a live demo, come and see me at lunchtime. So as you pan around on this map, what is visible on the map window updates the plots that are shown on the right-hand side. And then again, with things like those color and size drop-downs obviously change the size of the dots, but they also change what is shown within the plot windows, so that you can start exploring data and finding out things about it. And I guess do I see this as the ultimate end point of some analysis that I would say, look, here you go, client, I've done the work for you? Probably not. But is this like a really quick step that you can put in front of someone, whether that's internally or externally, and say, look, I've got these 2 data sets, or at least something approaching them, and like, is this the kind of direction we want to move in? What other information do you think we should have in that color column or in that size column, or what other stories can we tell? So there should be a Brave live demo here, but there is not. My laptop is there, and I am quite happy to do one. So other things on the path for this, because I've just shown income and expenditure on that, and maybe it's helpful to talk about some of the things we have have access to as an organization. Is we have various income categories around salary and benefits and pension and investment, all of that kind of thing. So we work, I think I'm live, yeah. We work with NatWest Group, who own RBS, and we have access to about 1.2 million customer records in a very anonymized form and controlled in the same way that NHS data is controlled for research. So we have an entirely separate information governance team who control and make sure anything I do is entirely safe for external consumption if it ever makes it that far. We've got information on expenditure around like whether it's committed or essential, so things around like mortgages or rents, things on quality of living, they're discretionary, uncategorized, that might be cash withdrawals, that kind of thing. And we're working with NatWest on getting more detailed data, but as you can imagine, like building up this level of trust for them to share data with us and us to demonstrate that we aren't doing anything bad with it and that we are enabling good things is quite a long journey. And from these data sets, we then, or these data points, we're then deriving extra indicators around overdraft use or disposable income remaining after you've sort of spent your essential money, and then like things around the proportion that you've spent on essentials and ratios and all of that kind of thing. And so I suppose this is what it looks like a bit in practice. This is some work we did for the Aberdeen Financial Fairness Trust. They changed their name halfway through the project, which is slightly confusing. And this is looking at how COVID lockdowns impacted overdraft use. So we've got younger, lower income groups in the bottom left and older, higher income groups in the top right. And we can see that sort of each dot represents a quarter, and you can see that big step change. That's when the pandemic hit. And generally, I mean, income's dropped a bit, but expenditure dropped more. And so we can see for all of the wealthier groups, their overdraft reliance almost completely disappeared. But for that low income group, it didn't really have any impact at all. And like they're the people whose income couldn't, whose expenditure couldn't change. That they were already living on the breadline, and having a pandemic didn't alter that for them. I mentioned climate change, and it's obviously a bit of a swing from the cost of living, but I imagine they're going to get closer in the fun times we have ahead. So again, this is perhaps what a data structure might look like, that we maybe have some kind of ID column, that we've got X and Y coordinates, we've got some kind of timestamp. In this case, we are looking at potential leaks or leaks of methane from gas networks. So things like that might be the Nord Stream sabotage or whatever happened on that in the North Sea that was in the news. Predominantly, we're working on looking at the US. So there's leak volume in there, and then there's information on the error and that kind of thing. And this ends up looking like this. And you'll notice that it's an incredibly similar plot to the one you've last seen, but now I've got dots across the mainland US with information there. You'll see that it's got fake data at the top, and for the eagle-eyed amongst you, the histogram looks very much like a normal distribution, because it is. So this is work with University of Edinburgh and Paul Palmer's group. There's more information there, but they're using the Sentinel satellites to classify plumes of methane leaks from infrastructure. So I mean, it's super interesting work, and as this progresses, that they can do this on sort of small scale basis, but actually ultimately we want to get to a point where they can, pardon the pun, pipe their data into the dashboard so that we can then start to see more live information. But again, this is demonstrating why this is useful, that we can take some fake data and put something in front of them and say, look, is this the sort of thing that will be helpful for your potential collaborators down the line? And all of this is made possible with free and open source software. For those who haven't spotted, those two previous outputs were made with R and with the Shiny package, which is produced by what was our studio until a couple of weeks ago and is now POSIT. And this is the fantastic super zip example. And you'll notice, actually, it's super similar to the two we've just looked at. And this, well, you can even see the button up there. It says get code. You can download the code and work on it. And actually, like, that has been super useful. And it's been a really important basis for the work that I'm presenting. But what's the secret sauce that I'm adding parameter files. They kind of sound old-fashioned and like they're not magic, and really they're not magic. But actually, it's super useful. So in the terms of the cost of living, this, whatever it is, 18 less than that lines of parameter file are what makes that dashboard different to the one on the methane leaks. So we've got something there about reading in the CSV file. We've got where our ID columns are, what the X and Y columns are. We've got some information about the drop-down menus, what the defaults are selected for the drop-down, maybe what the title is, where we want the center of the map to open up at, what zoom level, and then some bits and bobs about pop-ups. What does it look like for the methane example? Well, it's even less lines because actually 5 minutes, yeah, that's grand. It's even less lines because there's actually fewer columns. There's only that leak volume really, because plotting error in that way doesn't really make much sense. And the main things that have changed are things about the lat long are in different places. The map zoom is different, and obviously I've got names that are different. But that's actually effectively it. And for me, that's actually super powerful that I can just change those 15, 20 lines and be able to put a dashboard in front of someone and say, is this the kind of information you're after? Like, does this present this in a way that is helpful to you? So this would be the point when, thanks Tom, when I would show switching between the parameter files, and it is literally just a line of comment out the one parameter file and uncomment the other one. Paolo, who I mentioned earlier, is a wizard with make files. So at some point, I suspect we'll be switching to doing make files and various fancy deployments. But for now, it's commenting and uncommenting, read whatever parameter file. So back to the initial premise. Can we wireframe a dashboard? Yes, but I guess like that example of my understanding of a dashboard is I think we're kind of at that point that we're missing something. We're missing some content in that dashboard. And ultimately, we want that content to be real information, whether that's about cost of living or about methane leaks or whatever else. It needs to be real information for it to be useful for someone. But in the interim, are there useful things we can do about enabling innovation and enabling people to try out ideas that are not just a normal distribution? So my colleagues Victor and Nick have been working on what our comms team came up with as the smart agent simulation, and what we have affectionately known within the data science team as the uncanny Glen. No prizes for guessing which one I prefer, but I will happily toe the corporate line. This is another Dali, that is how we say it, isn't it? Yes. And this is, I think, for the uncanny Glen. So we have a cat in the uncanny Glen, and Victor uses this on all his presentations about it. And for those who are more operating in this sphere, you might guess that the smart agent simulation is agent-based modeling. And we've been using that as a way to generate synthetic data for various projects and clients, and for us to try out our ideas and all of that kind of thing. So what effectively happens is that we have some kind of country or region specific configuration file, I suppose very much like the parameter file I've just shown. We have various reference data about the population, so maybe from census and all that kind of things. They run through our magic black box, orange circle, whatever we want to think of it as, and out it spits various information about banks and customers and PDF statements and all of that kind of thing, in order for people to try out ideas. And that might even be us, that we have very sensitive data from our partners like NatWest. And when we want to try out say a new data pipeline, maybe we don't try it out on our actual real data. Maybe we try it out on some synthetic data first, because then we can actually really rapidly prototype. If it's it's good enough for us, it's good enough for lots of things. And actually it's been super useful and continues to be super useful. And one of the things we did super recently, lots of supers, one of the things we did recently was we worked with the FCA on their push payment fraud tech sprints. This is that idea of you get a text message saying, I've been locked in prison, can you send me 50 quid to let me out, or $5 grand to pay my bail or something, but it's not actually from your gran, it's from whoever who quite fancies $5 grand. So as part of this, we generated not just the bank and the customer data, we also generated synthetic text and phone records as well for people on this tech sprint to work with and try out their ideas. So I think it was around, I want to say it was 100,000, but it might have been 1 million customers. They were quite large data sets. So it was from Friday when someone sends you a 25 gigabyte file and says, can you just quickly check this for me, please? But that's fine. And so that was it was a really useful thing. I think that the tech sprint people found was actually, rather than having siloed data, which they maybe could have got from individual banks, they had potential customers across multiple potential customers across multiple banks and be able to see what's going on. And this is obviously limited by our own assumptions about how these agents behave in the modeling, but we are very open to working with people about trying out ideas, I suppose in the same way that you might in climate simulations, to say, let's try out what happens in this kind of context and see if our agents behave in different ways. For anyone who's been to one of my talks previously, I quite like OpenStreetMap data. And it's one of the things that I am spending a little bit of time trying to incorporate into the Uncanny Glen, the smart agent simulation. In that it will give us a lot more location context and make things considerably more realistic for our potential data sets. So you could see, well, actually, maybe within this postcode area, we have a lot of betting shops, and that means that people are more likely to spend money in betting shops, and that should be reflected in their bank statements. Or that supermarkets in this area are all Tesco, so why would we include an Asda for people to spend money in? Like, that just shouldn't appear. And I guess that adding this realism adds extra information and context. As I mentioned, because we're doing it in multiple regions, so we're also doing this for Germany as well. Having access to global data like OpenStreetMap means we can fairly rapidly adapt what we've got to other areas. And just about, I think we've got 2 left. I mentioned privacy a couple of times already, and it's really important to me, and it's really important to the organization, and I hope it's really important to you as well, that actually working with what I showed in those 2 dashboard examples is what we call random constrained data. So it's just from a normal distribution. We've got our good simulation-based synthetic data, which is this agent-based modeling, and then we've been sort of going around to real data where potentially the utility increases, but obviously we have extra burdens of privacy. And trying to balance out all of those issues it's part of the interest or fun, depending on how you want to look at it. But it's certainly a big challenge that I think we increasingly need to think about. We are always looking for people. We're currently looking for data engineers. If anyone is interested, please speak to me. But otherwise, thank you very much. And it's just about lunchtime, do you believe?
Great talk. Thank you very much, Mike. Does anyone have a question for Mike?
It can be over a sandwich.
Great. Well, in which case I won't delay lunch any more than I have to. After lunch, we are going to run 2 parallel sessions. Can I get a show of hands? One of them will be a post-GIS, is it workshop?
So there are 3 rooms. So one of them is about GWR workshop. So you work with your computer. So we want to know how many of you would like to attend that one. And the other one is the talk.
Yes, continuation of the talks. You don't have to have a laptop, but it helps so you can play along if you do. But can I just get a quick show of hands? Who's more interested in the workshop? We've got 2 or 3 there. That's good. Yeah, 4 or 5. So most people are, and that's great. We just need to.
You can
move
always
chairs.
change. Yeah.
You can change and things like that. We just want to get the chairs roughly right at the beginning. And just before we go back for the talks and the workshop after lunch, we'd like to get a quick photo of everyone on the stairs, or as many people that don't mind having a photo taken. So at 1:30 sharp, we'll meet by the coffee, and we'll just quickly go onto the stairs. Very nice staircase here. So have a quick photo, and then we'll run into our talks from there. So go and enjoy lunch.